Hello, my name is Xander Delashall. The hobby I decided to teach you about today is installing and running Geant4, specifically on Mac OS in my case. So I made this text file which contains essentially all the steps and commands you need to run to get Geant4 up and working. So first you want to start in your main user directory. In this area you want to create a new directory, which is just a Geant4 working directory. Or you can call it anything you want, just something to keep it separated from other files on your system. And then you want to install Geant4. A simple way to do that is just to either get it from the Geant4 website, or you can run curl or wget and you can pull it directly from online, and then you can just untar it with this command. So still in this same directory, you want to make a build directory and an install directory, and these are used for Geant4 for essentially everything it needs to process and run. After you do that, you want to start by installing some environment that Geant4 can actually run in. So you need root specifically, and root is used for the analysis portion of Geant4. The files that are outputted by Geant are in a root format. And so that's why you need to install an environment that contains root. So for this demonstration, I'll just show using Anaconda. It's just a simple way to install a root environment. So first you want to do a brew install Anaconda command. Then you want to initialize, and then you want to create the environment. So you can set whatever name you want to right here, and then you can set whatever version of Python you want to right here. For my case, I use Python 3.9. And then you want to activate that environment that you just created. And then inside of there, you want to do conda install and then conda forge root. And this just installs the root, which is for the analysis portion and everything, into your environment. Then you want to go back to this build directory that you had created earlier. And you want to run this cmake command. And the cmake command is essentially just initializing Geant4 into that build directory. It's getting everything pathed out correctly. So here it just goes to the main Geant4 directory, and then it goes to the install that you had created earlier as well. These are specific things for Mac OS, so this is for visualizing Geant4. This is to just enable multi-threading to just make processing a little bit quicker, and this is install data on, and this just means that it's going to install all the sort of physics capabilities that Geant4 has, so all the particle collisions and all the fundamental physics that Geant4 needs for simulation. And then you're going to want to run a make/j command, which this j command is essentially, you can put a number after it setting how many cores you want it to process with. So just depending on whatever CPU you have in your system, you can allocate a certain amount of cores. So in my case, I allocate 8 cores, and it just makes this installation a little bit quicker. And then you want to run make install. And then after that, you need to source this geant4.sh. So this is just sort of a setup file for Geant. So it just understands, essentially you're updating and telling it, okay, this is what I've done, and I'm ready to move forward, right? And so from this Geant4 work directory that you had created, you want to make a new directory, and this is where you're going to actually test Geant, or you're going to do sort of whatever you want to do. You don't want to mess with these initial directories you have created, because you don't want to sort of, you want to keep a constant of files that you can always revert back to a previous state if something goes wrong or anything like that. So it's better to just copy stuff into a new directory and run it from there. So here I am just copying a example from the main Geant4 directory, and I'm just copying it to this new one I created. And then in here you want to go into the B4D example that is inside of this basic. And inside of that B4D, you want to make a build directory, and this is just essentially, again, it's a sort of separation so that you can make multiple build directories where you're maybe testing different geometries, or you're testing different angles of the beam, or different particle collisions, or looking at different analyses at different times. You just make separate build directories. So make some build directory, call it whatever you want, go into there. run the cmake command again, and the cmake command will just essentially get everything that you had installed onto Geant and get it working into this local build directory. And then you want to do make, in this case I did make/J4, and it just makes it speed up a little bit. It's not as long as a process as this was, so you don't really have to allocate that many cores. And then you may need to activate your Geant4 environment again, but just always be sure you activate that before running this, because everything needs that environment to actually work. So then you can run this this executable. It'll be example B4D. It's created from this cmake and this make/J4. And from there, it'll go ahead and just open up the Geant4 environment, and you will see the visualization software, and I'll go ahead and show you what that looks like. So if I run that example B4D, it opens up this this visualizer window. So this is the sort of geometry that you're looking at the moment. So in this geometry, there is just some copper rods right here, and these are the sort of skinnier sections. And then between that is this scintillating material. So all that scintillating material is just something that captures light whenever a charged particle flows through it. So that light is outputted as some type of energy. So you can essentially use that information from the light to see what type of initial particle you had. So how you get this started is you need to set some sort of particle that you want to use. So here I'm just going to use a pion, which would create hadronic showers. So I'm setting it to a pion. I'm doing a 50 GeV pion, which is quite a high energy pion. And then you need to do tracking verbose 2. This will actually allow you to keep track of more of the information of what goes on inside of Geant. And then you can just do run beam on 1, and it will send the pion. So you see there's this initial blue line, and that's the initial pion beam. So there's some attenuation length before the pion actually, and it has an initial shower before more showers happen, and that's why you see this pion sort of travels for a little bit, and then here it sort of it hits its first nucleus, and this causes more subatomic particles to be created. You get just a ton of hadronic showers, and then it will continue in a cascading effect throughout the rest of the detector. So after this is ran, you can go back and you can sort of look at all this information that it's created, and this is what tracking verbose has given you. So you can go here and you can kind of see, okay, I right here it's saying that it created an electron, and from this electron you can go through and you can see, you know, how much of the volume it affected. You can see the kinetic energy, which the kinetic energy is sort of the most important thing. You can see how much energy was deposited in a single step, and then how much of that energy was deposited in length. And that just continues on and on. It'll give you a list of secondary particles. So here's some photon was created here, here, and here, right? And it'll just continue all the way down. So this is sort of the information that you would use for analysis in Geant. So the idea is that you have some detector you're working with, and then you build this geometry into the simulation software. You simulate the detector, and then you can sort of test performance of whatever you're trying to achieve with this particle detector. There's a bunch of different visualization options for Geant. You can change perspectives. Here, this is just a 2D geometry, so there's not really a whole lot going on. I can't really change perspective and look at anything else. But if you can make 3D structures, then you can change. You can look at where your beamline's coming in. And essentially, this is just a really good software for testing particle physics. And if you're just interested in particle physics, it's something that can get you sort of learning and get you practicing. And it's a really good program. It's a hobby that I've had for a while, and I work with it professionally, but I also just enjoy it on the side. It's something I enjoy doing quite a bit. So this was the end of my Geant4 installation tutorial. Again, here's all the information to install Geant, and if you run into any errors, most of the time you can sort of just find those solutions on the internet. They're pretty common errors, so someone will have a fix. But thank you for watching my tutorial.